In this motorboat question, the question that we're being asked now is how far downstream is the boat when it reaches the other side of the river? So just a little bit of background of what this question is asking. We have a motorboat that starts on one side of the river and it's trying to move to the other side. However, you'll notice, well, first of all, the boat is moving at a pace of 16.0 meters per second. That's the boat's own velocity. However, it's being pushed a little bit off course by the river's current, and the river's current is moving northwards at 1.50 meters per second. And so what I did was I showed this little these two pathways here on the river. Then I replicated that here. Whoops. Then I replicated that here on the this part right here. So you'll notice that it takes the shape of a triangle. We were able to figure out some of the stuff here by using some Pythagorean theorem and trigonometry functions in order to solve for the values here. So we were able to find out some crucial components here. Two of them that we're going to talk about here in this video is the angle that we just solved by using the velocities earlier, and that angle that angle is also the same one we're going to be using in order to solve for our distances. Now, the question in particular is asking how far downstream did the boat reach. So you'll notice that although the boat was trying to travel eastwards, the current did push it a little bit off course. It went northerly of its easterly direction. And so we want to know how far, basically this little point right here, how far from here to here did that boat land. I'm going to go ahead and remove the velocity vectors because we're only focused on the distance vectors now. So all we know is the angle at which the boat was veered off, and we found those by looking at the velocities, and that angle is going to be the same angle for our distance components. And all we know so far is the adjacent side of the triangle. And what we're looking for is the distance from where it landed to where it was supposed to land. So in other words, we want to know how far downstream. So if the boat landed here, how far is this from where its original landing point was supposed to be? And so we're looking for this side in particular. We're actually looking for the opposite side of the triangle. As you notice that this side is actually opposite of the angle itself, so we're actually looking for that side. And because we know the adjacent and the angle, we're going to actually use our tangent equation. Again, keep in mind we're going to be using our SOHCAHTOA mnemonic, and the only one that we can use for this question is TOA, because our TOA talks about both the opposite and the adjacent. We have the adjacent, we just got to find the opposite. And so the equation is tangent of theta equals opposite, which is your numerator, that's your second letter in this mnemonic, divided by your third letter, adjacent, that goes in the denominator. So now we have an equation that looks like this. Next thing we're going to do is we're going to plug in our values. So tangent theta is tangent 5.4 equals opposite, that's our unknown, over adjacent, that one we do know, it's 1,360. Now we can rearrange the equation and solve for it. So all we're doing is going to multiply 1,360 on both sides, just like that. That cancels out, and now we're going to solve for our opposite right now. So 1,360 times the tangent of 5.4 gives us an answer of 128.5. 128.5, or we can just say 129 meters. And so that is my adjacent, which is also known as the distance along the y-axis, how far the boat landed from where it originally started. So that's actually my distance in regards to the y, and that's how far downstream my boat went.